this is the heading. But once you've made that heading, I'd like you to make a tiny little adjustment. Because I think index laws, maybe, even though that's what they're called and it's what we're going through today, it's possibly not the most accurate description of what we're looking at. Here's how I'd like you to modify your title. Index laws, I think a really better way of saying this is not index laws, but index shortcuts. Because that's what these are. When you hear the phrase index laws, I don't know what that evokes to you. To me, when I hear index laws, I'm kind of like, oh, you better memorize these. They're really boring, okay? You better keep them. Otherwise, because they're laws, you'll face the consequences, okay? That's what happens when you break the law, right? So you got to memorize them, you got to know them, and then you have to follow them. Otherwise, so help you. But actually, I'll come to your question in a second. Actually, these index laws, right, what they are is ways to do things faster, right? Ways to do things faster. That's what shortcuts are, right? It's like, look, I can get from Cherrybrook to Epping, and I can take all the main roads, and it'll take me this long. But if you learn a shortcut, you take some of the back streets, it's the same thing. You've got to get from A to B, but you'll get there much quicker, okay? So that's what these index laws really are. They're shortcuts. And we're going to look at 5, okay? Now, Daniel, your question?
On the left, what's the red word?
Yeah, it's like
Memorize. And then keep. As in, you got to keep laws. That's what you do with laws, don't you? So these are a different kind of laws. Okay, now we're going to begin. And I'm actually going to ask you to write for me 5 spots, 5 lines, and we will fill these in as we go through the lesson. 5 index laws that we're going to develop, right? Index shortcuts. You already know 2 of them, right? I'm going to state them for you, and then we'll have a look at some examples. Okay, so here's the first one. I'll give it to you as a law, and because you've seen this one before, then we'll give some examples after. So, if I have some number and it's raised to a power, right? So A and M, they're both just numbers. Right? They're both just numbers. By the way, M's the power, or the index. What's the A called? It has a name. Yeah.
the base.
It's the base. Very, very good, right? So drop the base, right? Now, you got your base, raised to a power. Now, if I multiply by another number with the same base and its own power, I'll just wait till we're all ready. It's not really that I mind all that much. I can talk over you. I'm loud enough. It's just that you are stopping everyone else from actually concentrating. Is that okay?
Which one?
Well, all of you, but particularly. It doesn't matter who I'm talking to. Let's try again. When you're multiplying 2 numbers, same base, the A is the same, but the powers are different, right? What do we do to these powers? It's going to be A to the power of, no.
Whatever n plus n equals.
Fantastic. You add the powers. Okay? So, let's just give you a quick example of that. For example, okay? How about we do 2 cubed, which you can work out, right? But that's not what I'm interested in just yet. If you multiply it by 2 to the power of 4, okay? It's going to be 2 to the power, we're going to follow the law here, and it's 3 plus 4, which is 7, okay? Now, remember, it's not so much that, I can better learn this, right? It's just that this is the fastest way to do it. It's a shortcut, right? What would the alternative be? The alternative would be to say, well, what do these mean? What is 2 cubed? What is it actually, like, not the value, what does it mean? Yeah.
3 times 3 times 3.
Fantastic. I mean, 2 times 2 times 2, 3 times, right? So I could do that. I could write that out, okay? And then I multiply by 2 to the 4, which is the same thing with an extra 2. 2 times 2 times 2 times 2, right? So I could write that all out, and then I could count out 1, 2, 3, 4, 5, 6, 7, and say, oh, cool. It's 2 to the power of 7. But how long did that take, right? And if there were bigger numbers, if it was 2 to the power of 30 times 2 to the power of 40, I don't want to be sitting there writing 72s, Okay? So this is just a faster way to go about it. Fantastic. This law here, right, the multiplication, when you multiply numbers of the same base, you add the powers. It's got kind of a reverse twin, which is when you divide. Oops. If you've got numbers with the same base, but different powers, and you divide them, okay? Now, just like multiplication and division are opposites, right? Here, I should have, well, what do I do with the powers? Yeah, Jonathan.
Minus them?
Good, I'm going to subtract m minus n, okay? Again, let's do a quick example and you can see what's going on, okay? I could say 2 to the power of 5 divided by 2 squared, okay? Now, I'm going to use the law and you can see it's going to be 5 minus 2, which of course is just 3. Okay, now just for the sake of illustration, again, let's just do it out in longhand so we can see what's happening, okay? 2 to the power of 5, 2 times 2 times 2 times 2 times 2, right? Just to make it super obvious, when you divide, that's the same as a fraction, yeah? I'm going to put a big fraction line there, and how many 2's will I have on the denominator? 2 of them. 2 times 2, right? So you can see, just like with any other fractions, you can cancel things here, can't you? Cancel, cancel. You can do it again. Cancel, cancel. Right? So I'm only left with these 3, which of course is 2 cubed. But isn't it so much faster to just go straight there? Right? The index shortcut is so much more efficient. Okay?